Alright guys, last question for letter B on 5.5. Same type of idea. So you're given a base length of a square, so the base length is just 1. A base length of 2, well, let's go back to 1. So if there's a base length of 1, you have 1 tile. Okay, these are like ceramic tiles, let's say in your kitchen or whatever. If you have a base length of 2, you have 4 tiles. If you have a base length of 3, how many tiles? 9. So let's see again if we can get a pattern over here. Okay, so first differences, second one minus the first one. Uh, 9 subtract 4. So you can see that there's already going to be a pattern over here. So 3, 5. Next one's got to equal 7. So let's guess what's got to go there in order for that to equal 7. So base length, so it's something subtract 9 equals 7. 16, right? Okay? And now again, linear or nonlinear, well, the first differences are not equal. So since the first differences are not equal, it is non-linear. Now let's see if we can come up with an equation or a formula. So again, let's call this guy capital T for tiles. Let's call this guy lowercase l for length of the side. So tiles equals, let's see if we can test this. So let's put a length in here. So if the length was 1, right? How do we get the number of tiles to equal 1? Well, if you square it, let's just test it. Okay, because again, if you look here, 3, 5, 7, right? There's a pattern, and if there's a pattern, you know from the previous couple questions that it's got to be exponential, so there's got to be an exponent there. So let's test it. If L is 2, if I put a 2 in there, 2 squared, 4, checks out. If I put a 3 in there, 3 squared, 9, checks out. So now I can guess for 7 tiles. So for 7, or for a base length of 7, for 7 base length, we go capital T is equal to 7 squared. 7 squared, 49 tiles. Okay?